Hi there folks, I hope you're enjoying the SDL2 series and are ready to learn some new cool stuff in this lesson. In this lesson I'm going to do a little bit of live coding and start building in some abstraction. The reality is that we've learned a lot of neat stuff in this series so far, but we're going to want to start abstracting it in a way that makes it a little bit easier for us to build programs. That is to say that the C API that's provided is very handy and gives us low-level control over everything, but there are going to be some redundant or repetitive tasks that we're going to do, such as drawing a textured rectangle. So in this video, I'm going to go ahead and show you how to do that abstraction, and hopefully you can start thinking about how you also might build some abstractions. So let's go ahead and dive into it, some live coding. So here we are, and I'm basing this lesson off of a previous lesson in this series. That was how to just draw a textured triangle, or rather a rectangle, excuse me. So if I go ahead and run this code, you might have recalled in a previous lesson, we had some window that looked something like this. We were drawing lines and then eventually a rectangle with a texture applied to it. And if we go ahead and look through this code here, you'll notice that the steps needed to get a textured rectangle up and started are, well, we need to create a surface, we need to create a texture, remember to free that surface, create the rectangle, and then handle the drawing of that actual rectangle, which is down here, where we're actually copying this texture into our SDL render. And then we also have to remember to destroy the texture as well. So with that in mind, if we're just trying to get a textured rectangle on our screen, we can probably abstract some of these details. Now, perhaps in future lessons, I'll also talk about how we might want to manage our resources in a resource manager class. But for now, let's go ahead and just create a class and move up our details for creating rectangles. So I'm going to go ahead and do this in the main for now to get to work, and then show you how to separate this into separate files so you can organize your project a little bit more logically. So let's go ahead and create a class here called textured rectangle. And just as a reminder, something I like to do is to keep the documentation in front of me. So I like going to the search, hitting on APIs by category, and then we are in 2D accelerated rendering or under video. So we can find some of our functions here that may be useful for rendering, as well as the rectangle functions for our SDL rec struct. I'm just going to go ahead and leave this here for now, just a reminder for you, and we'll just grab some of this from the code. So anyway, to continue with our abstraction, we need some sort of constructor for this particular class here. And we're also going to need a destructor as well. And typically when I implement the constructor and the destructor, I'll probably need the copy constructor as well. This is sort of the rule of three or the three amigos, or depending on how you've learned it, the idea that you need the copy constructor and the copy assignment operator as well, anytime that you define your own constructor or destructor. That's a good practice and can be found in a future C++ series that I do. Anyway, let's go ahead and start merging in some of the old work that we did with our textured rectangle and go ahead and get things set up. So I'm going to go ahead and just copy this code that we had previously into our constructor. And this code was responsible for setting up our rectangle and setting all of the properties of that rectangle. And then let's go ahead and grab our code in the actual main loop here for drawing our rectangle. I'm going to go ahead and clean up some of this other stuff that we had where I was just teaching you how to draw lines, draw the rectangles, and just grab the render copy. Now, where should I put this render copy? I'm just going to have it hang out here for a moment. And finally, the last detail that I need from my rectangle is we need to make sure that we destroy our texture. Okay, so let's go ahead and start designing our class here. I'm going to make this just slightly smaller here, just so you can see more of the code on the screen at the same time, so you can get an idea of the structure again. So, destroying the texture. That's probably part of our destructor here. And we do have to make a little bit of a decision here about what we want users to create or instantiate their rectangles. And my goal is here, since I'm going to be creating lots of potential textured rectangles, is just to make this easy and have a constructor that can handle, say, the image that we want to create, and then immediately create a textured surface from that. So I'm going to go ahead and take the file path for the actual rectangle that we want here. And remember, since this is a C-based library, we're working with C strings here. In fact, let me make this window just a little bit bigger for folks, and I'll go ahead and increase that font size while we are focused here. Okay. Now, what do I also need to have knowledge of? Well, I need to have knowledge of this renderer when I'm creating the texture as well. So that's got to be part of all of our functions, essentially. And potentially, I would also have to set the X, Y position of the rectangle and the width and the height. Okay, so we're starting to get a little bit out of control here in the number of parameters that we have in our rectangle. So here's where we have to make some decisions about our API. And you can always go back and refactor. And my goal, at least in this lesson, is just to have the ability to create some textured rectangles more easily. So let me go ahead and just simplify this quite a bit. And I'm going to go ahead and just provide some defaults for this. And we are going to need the SDL rect as one of our member variables here. Okay, so this is going to be private. And I want to also take care of the render copy here that we have. And I'm going to go ahead and put that in some other functions like an update and perhaps our render here. So let's go ahead and handle that. Okay, so there we go. All right, so now what else do I need here? Well, I need to figure out how we're going to size this rectangle and perhaps take care of some of those things. So let's go ahead and write some setters here. So I'm going to call set rectangle properties, the X, the Y, the width, and the height. And let's go ahead and set these up for our rectangle. And remember, I've refactored this as M rectangle here. So I'm going to go ahead and do a substitution here. Rectangle for M rectangle. And there we go. And these should be set appropriately to the X, Y, and W positions and the height position. X, Y, W, and height. So I quite like this, that it's just one function now. I don't know if I quite like this name, and some folks might also argue that having getters and setters for some of these variables, why not just make this rect public by default so that I can access those values? Well, I'll tell you why, because I typically do like to protect my interface and be a little bit more conservative, make things private by default. If we're thinking about some things like performance, or perhaps there's other considerations, or we don't care, maybe that's okay. But it's a little bit cleaner to have getter and setter functions, even in the C++ language. Okay, so now that we've done that, and let me get rid of this search here, let's go ahead and visit our texture rectangle. We're going to notice that a lot of these functions, especially when we're doing things like texturing or drawing, need the renderer here. So we're going to have to pass that in. So you have to make a decision about how to do that here. So for instance, in this particular case, I think it's going to make sense for us to, for our textured rectangle, allocate a surface, then texture that surface, and then, create a texture from that surface, and then just go ahead and free the surface. For now, that's going to be fine. We'll have to improve our abstraction a little bit in case we make a lot of textured rectangles that have the same surface color, for instance. So that still doesn't solve our problem, because we're going to need to pass in an SDL renderer here. And we'll go ahead and see that we have that here. SDL render, I'll call it render here. So if I want to be a little bit careful here, because if I'm passing, remember we're using pass by value semantics here in C++ by default. And if we're a little bit not careful here, this could cause some performance, meaning that SDL render might be a big struct that has to be copied every time. So I'm going to pass this in by reference here. If you can get away with it, you can pass it in also by const if we know that it's not going to change. Now, since we might be changing the state of the render, I believe we need to make this non-const. I'll try it later just to see if we can do an optimization there, but for now, that's okay. Okay, so some other things I'm going to want to refactor here is I'm going to want this texture to be one of our member variables here. And I'm going to go ahead and make that a pointer so that we can hang on to it there. So let's go ahead and add SDL texture here and M texture. Then part of our render function will also be M texture, and our render needs to, well, take in the SDL render again. And this is, again, a design decision here where we need to think about, let me make this render, should in the constructor be the one place where I create this textured rectangle and it always belongs to this particular render? Because we could have multiple. And if that's the case, I probably want to just hold on to a reference of this so that the user doesn't have to constantly pass in the renderer here as an argument. So that could be a particular design decision that we want to use, but for now, I just want to show you this abstraction and give you some things to think about. Okay, so we have the ability to create, with our constructor, the textured rectangle based off of some surface that's going to be loaded from memory here. And we're going to convert that string here. So we'll need the string library. So let's go ahead and set that up. And then once we're done with our surface, we're going to immediately free it. Okay, so I think we're good to go with our constructor. And for our destructor, we will destroy the texture. That's some memory that we have allocated here. And we'll be good to go. And our rectangle itself is just created and will be destroyed on the stack here. We might want to change that in a moment, but let's go ahead and see with this much so far if we can in fact create textured rectangles and take a moment to fix any syntax errors that I've made. So let me go ahead and make this a little bit larger, flip my windows, and let's go ahead and try to rebuild this. And I'm going to go ahead and grab this code from the top. To compile on Linux, and a few errors here at line 15 from the renderer here. It says that we cannot pass this in. This actually needs to be cannot create SDL render to SDL render pointer. So this should actually be a pointer that we're passing by reference here. So we could do this in that manner. And we're going to have to fix this the same here. And in our render function, let's see, we have M rectangle. Okay, so let's go ahead and compile that, and it looks good to go. So where I want to go from here for a moment before I take this another step further is just to go ahead and see, can we create one textured rectangle by instantiating? It's in our code. We can just do this locally in our main here and create one textured rectangle. I'm just going to call it rect. And we need to provide the render that we're passing in here. And this is a pointer to one, so we should be okay. And then the file path here, which I believe is images, and we have a test BMP. And let's go ahead and see if that compiles. Compiles, which is good. And let's go ahead and see if we can call our render function on our rectangle here. And again, it's important that we call this after we have cleared our screen, which is at the following. So let's go ahead and do our rect here and render. And something that I'm also going to want to do in the loop, though, before I actually render, is to set those actual properties. So if you recall, we have set rectangle properties, and we should give an X, Y, W, and H for our particular rectangle. And perhaps there are some reasonable defaults to give in our constructor here for this rectangle, but I'm going to go ahead and just set them here. Set. Let me go ahead and just type this out. Oops. Rectangle properties. The X, I'll do 20, 30, and this will be 200 by 200. Okay, so let's try to rebuild. And make sure that we pass in our renderer here. So that was part of our design decision when we said we needed to always pass in a renderer. because we might switch if we have multiple windows. Again, that's going to depend on the application or the common use case that you think you might have. Okay, so let's go ahead and try to run this program here. And if I go ahead and run this, you'll see that we now have our textured rectangle here. And it's at 2030 and it's 200 by 200 with some image here. Now, at this point, you can go ahead and leave the video if you like, and we can call it a day there, and you can make your tweaks as you want. But what I want to go ahead and do is improve our abstraction here just a little bit here so that you have something that is functional and that you can use for textured rectangles. The good things that we have done, for instance, are being able to just simply load a file, create that surface from the pixels, store them in this surface, then create a texture from that surface and free it. So we don't have to remember any of those things. Maybe we want to think a little bit about our setter functions here and how we want to use them, but that's okay. And we do have our destructor, which takes care of cleaning up the texture. So I do like those things. Now, one thing that I'm tending to do more and more in my programming as well is to not want to worry about various pointers that I have in my code. So one option that you could have is you could make things like SDL texture into a smart pointer, for instance. That would be up to you. Since I have a C-based library, I'm going to stick to having pointers, at least for now. So that's sort of what's compatible with the library. But if you're worried about memory leaks and so on, that is one of the improvements that you can make. Now, the other thing that you might want to do, again, is to go ahead and have a copy constructor, copy assignment operator, and even things like the move and move assignment might be things that you want to handle as well in C++, depending on your API. But for now, the one thing that I want to do that I think is a must is to move this to a separate file. So let's go ahead and get rid of that. And I'll go ahead and create a new file. And I'm going to call it textured rectangle HPP. And I'll go ahead and paste in our class there. Now this is using SDL functions here. So I am going to have to make sure that we have a header there. And I was using the string as a parameter here. So I'll go ahead and include this. Okay, so let me go ahead and clean this up here. So I'll go ahead and save that. And I'll include our textured rectangle here. And that's an HPP file. Okay, so now that I've made that simple move, let me go ahead and just try to recompile at this point. And it should still work as expected. And what I'll do now is go ahead and close this main so you can see everything here. Now, again, if we're providing a good abstraction, many of you have been using C++ for a long time now, we probably shouldn't have everything in this header file. So I'm going to go ahead and break that out into a separate CPP file. Now we like to split up the C++ file, the header from the implementation, for one reason, because then our clients only really need to see what's in the textured rectangle, for instance. They could see the constructor, destructor, that they have a set rectangle properties, function available, and so on. And that should be fine enough. Okay, so let's go ahead and create that abstraction here. So I'm going to go ahead and make this window a little bit smaller and just show you the abstraction that I'm going to do. And I'm going to have a textured rectangle CPP file here. And that's going to need basically all of our implementation here. And I'll paste that in. And I'm going to need all of the code here. Let's go ahead and indent it a little bit nicer. And we'll need, again, these libraries here, or at least the third-party SDL library string will have already been included, so I'll get rid of that. Actually, I'll leave it in because it is visible that I need it here. So I like things to be part of the library there. And now I can start cleaning up my actual header file, just so you can see how this is done. Destructor. And let's just go ahead and keep cleaning this up. And there we have our actual interface here. We would want to go through and go ahead and add some comments, for instance, to these functions. And I like doing doxygen style, so often that can mean 3 slashes or with various multi-line comments. But I'll leave that for a later video, or perhaps if we build something more significant to that documentation. Okay, so this is our interface, and let me go ahead and just give these a few comments here. Render, update every frame, and so on. And we get the idea. Now I need to, for each of these member functions here, tell the scope in which these functions are found. So for instance, that means I need to write textured rectangle and add the colons here. And I'm going to just copy this line here because we're going to need to do this a few times. Now that we've done that refactoring, let's go ahead and see if we've made any errors. Now, as soon as I hit compile here, I'm expecting at least one error or a cascade of errors to take place. And in fact, we have a few semicolon errors here. So let me go ahead and fix those. And that's in our interface. So one here, and let's go ahead and recompile. And you're going to notice that we get undefined reference to each of these functions. Well, that's because we haven't compiled our CPP file here. So we're going to go ahead and need to do that in our command line here. And let me go ahead and put this so you can see on one line roughly what is going on here, that we have to compile our main file and then our actual source code for our textured rectangle. That's a CPP file. Okay, so let's see. Few more errors here. Now, what happened again? And this always happens whenever I do my abstractions, that I forget to include textured rectangle.hpp. That's our interface. Let's try once more. And just a silly mistake here. I actually want this to be not texture rectangle, but textured with a D here. So I'm going to go ahead and fix this. And these are the kinds of things that happen in live coding. And let's try again. Looks like another spelling mistake here in our main file this time. And go down to our declaration, textured rectangle. Compile, run, and here we are. Now, this isn't much fun at this point, so let's go ahead and try to create a few more of these textured rectangles. And finally, we have a program here where I can render things. And oops, nothing showed up. So let me make sure that they're constructed properly. I'm going to go ahead and run this one more time. And this is something that's subtle that hopefully you've made it through and are watching this far in the video. But let me compile the program. Let me go ahead and run it and go ahead and display the empty window. Now, why is this an empty window every time that I run the program? And I was a little bit perplexed here, but I needed to think a little bit about how SDL2 is operating. Because every time that I construct one of these rectangles, well, since I'm doing it here within our actual logic here, this textured rectangle is only temporarily allocated. And in fact, every time that means that this loop is going to destroy in video memory this texture. If I go ahead and move over to my destructor here, we can see that we're destroying our texture. So I do believe that our rectangles are in fact being rendered. They're just empty, unfortunately. So how do we fix that? Well, now we need to manage the lifetime of our objects. So one way we can do that is to have a pointer here. And this is where I mentioned before that I want to be a little bit careful with how I manage my memory, perhaps within my implementation, and how I have control over that. Well, that's sort of on the API and implementer's perspective. But now, as the actual user of this library, I want to make things easy. I'm going to use shared pointers to make this a little bit easier on myself here. So I'm going to go ahead and include the memory library here so that I have access to shared pointers here. So now this is going to be a vector of shared pointers here. That means that every time when I create one of these textured rectangles, and I'll go ahead and just break this out a little bit, that I have to manage the lifetime of these. And that's okay with me, in fact. I actually don't want the video memory or the destructor being called inadvertently. So let's go ahead and handle that. So what I'm going to go ahead and do here is create a shared pointer here to my textured rectangle. I'll just call it rect, and it takes in a render and our images and the test.bmp image here. Okay. And what we want to do here actually is, well, we have our rectangle here, is actually, again, use the standard library make shared for a textured rectangle. And I'll go ahead and move this aside. And in fact, I'll make the font just a little bit smaller so you can see everything fitting almost on one line. There we go. And now I'll push back these rectangles, which are shared pointers. And then we'll be able to use these accordingly here. So let's go ahead and set up our renderer here. I'll change our code a little bit just to instantiate or initialize these particular sizes one time in our loop. I think that's a little bit more efficient for us. So let me go ahead and set this up here. And let's go ahead and leave it at that. And since we're using shared pointers, we need to make sure that we're using the arrow here. And let me make sure I have the arrow here. I do. Okay. Okay, let me try to rebuild. And since we are pushing back values here, let's make sure we have a semicolon. Recompile. And we need a loop here. And let's go ahead and since we're throwing out some new C++ features, my intent is to iterate through all of these rectangles. So let's go ahead and just do auto rect here from our rect structure. And go ahead and just handle each of these rects here. And it builds. And when I display it, it runs. We get some amount of these textures that are tiled one after the other. Now perhaps I could spend a little bit more time spreading them out or doing something a little bit more intelligent with this algorithm here that I have here. And I suppose that would be much better. In fact, it'll probably make sense to make the columns 1 here. And perhaps this value a little bit bigger here. And again, I don't care about this being perfect. I just want to display a few objects and show you that we have textured rectangles and that you have some abstraction here. So you can see a few of them tiled here. Maybe use a nested loop in this instance here. Okay, so anyways, you get the idea of the actual lesson. Let me recap briefly what we've built here to now have an abstraction. So on the actual development side, what we have is two new classes here. And we'll just pay attention to this textured rectangle in the bottom left corner of your screen here, where we have some ability to load pixels into a surface and immediately create a texture from it, and then manage some properties all within one class here. And the actual implementation details have now been separated out into a separate C++ file. In fact, this will help some of our compilation times as well if we're only making changes in certain files once we start using build systems such as make or tools within your compiler, or rather IDE if you're using something like Visual Studio to follow along with these lessons. And then finally on the client side, we went ahead and made 10 textured rectangles, although they're sort of scattered around here, but you can play around with that code, and draw them all at once. And since we're using some new features like smart pointers, it may be useful to note that that'll handle the reclamation, or the ownership rather, of freeing our memory when it is in fact actually free. So we had to make a little subtle change here and be a little bit careful with our implementation. So I hope you enjoyed that video. I hope it was useful to see part of the abstraction, and we'll keep continuing on with this as we play around with rectangles